So that's your fictitious force. Okay? And fictitious forces are always present as long as your moving frame is accelerating. So in our expression, uh, in our discussion here, okay, this inertial term or this fictitious term is brought about by an accelerating, a translational acceleration of the moving frame. This example, on the other hand, is brought about by a rotating frame. Okay, so this fictitious force has a special name in this case. This fictitious force is actually called the centrifugal force. And this real force is called the centripetal force. Okay? So the centrifugal force and the centripetal force stem from the fact that your reference frame is moving in a circular, is changing direction. So this real force or the centripetal force is measured or is observed with respect to the fixed frame, and then the centrifugal force is expressed or is observed in the moving frame. Okay? There's another type of uh, there's another type of uh, non-inertial or fictitious force, and the effect of which is called the Coriolis force. Okay, so imagine you are on a merry-go-round. So so this is you, and this is your friend. Now, when you throw the ball towards your friend, okay, the on a rotating merry-go-round, so the tendency of the ball is to turn in this direction. If you are observing in the if you are fixed with the moving merry-go-round. But if someone observes from the outside, let's say there's a drone taking a video of so for example, you have a drone that takes a picture of you playing in the merry-go-round that is fixed with respect to the ground. So from the reference point of the drone taking your video, the merry-go-round turns. So if the ball is thrown back to you, is if you throw the ball toward your friend, your from the reference point or from the viewpoint of the drone, that ball will move in a straight line. Okay? It's hard to imagine, right? Okay, so I have a video here that I want you to watch and you see what happens. Okay, so this is from MIT, Mapua Institute of Technology, Department of Physics. De joke lang, MIT sa US yan. Okay, so you have a rotating platform and there are two students from each side. So right now, this lever or this platform is at rest. So this guy will throw the ball to his friend like this. Okay, and then like this. Okay, like that, like that. Okay, now the ball is moving. So you will notice that the rotating frame is now rotating. So when the ball is thrown, you will see that the ball is deflected. That deflection that deflection is caused by the Coriolis force. So you will notice that the okay this point, okay, let me go back. So the viewpoint used is at rest with respect to the ground. So that's why the platform is moving. So if you're going to notice the ball, as mentioned, here, the ball should go straight. Okay, so the ball will go straight if you are observing in the fixed frame, as you can notice here. Okay, so this ball, if you're going to re-observe the ball it thrown from this point, it actually moves in this direction. Okay, do you see? Okay, so this is what I'm talking about. This ball will move in a straight line. Because remember Newton's first law, this ball should move in a straight line if there are no other external forces acting along that axis. Okay, so because our reference frame right now is fixed to the ground, so therefore this ball will follow a straight line. Okay, this is if there are no forces acting on this ball. Because we are observing in an inertial reference frame. So right now, we are observing in the rotating frame. So that means we are in the non-inertial reference frame. Okay? So when the ball is thrown, like this, nakita nyo? You see? So the ball veered towards this direction. Okay? So that means there is an extra force that causes this ball to turn in this direction. That fictitious force is called the Coriolis force. Okay? So this path of the ball, Newton's first law states that this path should go straight once it is in air, but it doesn't behave that way. It veers this way, and that is because there is a fictitious force that causes this ball to turn in this direction. So without adding that Coriolis force or that fictitious force, okay, Newton's law will not be valid for this ball as it moves in this direction. Okay, so in the following weeks, we're going to express these fictitious forces as uh, as mathematical expression so that you understand in more detail how this forces is brought about by accelerating reference frame. Okay, so you notice that if you change the direction of rotation, the direction of the deflection or the Coriolis effect changes as well.